Title for my FYP is Cervical Cancer Risk Prediction Using Supervised Learning Method. So for chapter 1, so basically it's about how to predict cancer is time consuming process that involves frequently results in pathologies disagree. Computer aided diagnostic techniques also showed promising in terms of increasing diagnostic precision, and early detection and prevention on the other hand can dramatically lower the risk of death. Cervical cancer should be able to detect as soon as feasible with early stage screening, and there's new ways for predicting cancer therapy outcomes early on, such as supervised learning methods, SVM, support vector machines, classification, random forest. They can extract patterns and relationships from large data sets so that they can accurately forecast future cancer outcomes. So for my problem statements, the challenges are able to predict cancer risk before an individual gets detected by cancer by using the best performance supervised learning model. And the motivation for this is so the prediction is important because machine learning model prediction allows businesses to make highly accurate guesses as to the likely outcomes of a question based on historical data. The solution is by using methods such as SVM classification, random forest and decision trees, and also naive Bayesian methods to see which is the most performance model in terms of sensitivity, speciality, and F1 score. The aim and objectives are, first, my aim for this research is to apply supervised learning methods using cervical cancer datasets and to choose the best model with a high performance to predict the risk for cervical cancer. My three objectives are to be able to study the cervical cancer risk and methods to predict them. Second is to implement machine learning models for predicting the cancer risk. And lastly, to compare which supervised learning models has the highest performance in predicting the cervical cancer risk. My three main research questions are: what are the models available to predict cervical cancer? Which supervised learning method produces the best performance model? And lastly, how to implement machine learning model into the risk for cervical cancer. My research significance is to practice machine learning techniques to cancer risk prediction modeling in this paper, so that the outcome we would get from this is to help contribute cancer research departments and medical industries to help predict cancer in individuals faster with the better performance model in order to reduce cancer detection in people. This is my research contribution. So this research provides a comparison among several types of supervised learning methods to pick the highest performance model to predict cervical cancer risk among women efficiently and accurately using the most best performance supervised learning model. So basically, the research scope will contain and focus on predicting the risk state of cervical cancer virus which affects women. And for this research, the data set is obtained from Kaggle, and the measurement of performance based on supervised learning method to determine the best performance model, and the programming language used for this is Python. So for chapter 2, this is my literature review. So I did few research on other papers and obtained the result. So the related study description covers support vector machines, classification, random forest, decision trees, and naive Bayesian. So my proposed solution for this is to implement the models SVM, classification, decision tree, random forest, and naive Bayesian in my research and conclude which of one of the most following models would produce the best performance in terms of accuracy, sensitivity, specificity, and F1 score. This would be a comparative study in order to determine the best model used for cervical cancer risk prediction studies. For chapter 3, this is my example of an overview for my dataset, and the dataset is obtained from Kaggle. This dataset has been used in other research such as the one conducted at PCA, cervical cancer risk classification. So this is my data dictionary. My data contains 14 attributes and 859 samples. So for my data exploratory, this is my operational framework. So firstly, my initial study, data processing and research planning, we cover for my literature review, data collection and data normalization. This is my first objective, and this will be done in my FYP1. For the development phase, which is comparison of the machine learning and evaluation phase, will be done in FYP2. For my research, confusion matrix is used to predict the model performance in terms of accuracy, precision, sensitivity, and specification. The software and hardware requirements involve a PC with Intel Core i5 processor, Windows 10 operating system, and a 4 GB RAM memory is required for the study. For my chapter 4, I did data normalization. So the data has been normalized here, and for the data normalized, which has 0.0, those are states. So the reason for data normalization is to improve the accuracy and integrity of my data, identify duplicate data, and also the goal for this is to change the value of numeric columns dataset to common scale without distorting the difference in the range. So for my training and testing, I'll be using 70% dataset for training and 30% dataset for testing. So this is my data division arrangement. 70% for data will be used for training and the remaining 30% will be used for testing. The dataset instance will be partitioned. So in order to detect missing values, I've already did some research on that, and the total number of missing values are 0. And this is the data visualization for age versus number of pregnancy and also number of sexual partners versus first sexual intercourse for both scatter plot and bar. So for my chapter 5, the primary research study regards of cervical cancer risk prediction, which includes all risk factors and biopsy. And the objective 1, which is to study cervical cancer risk and methods to predict them, has already been achieved. So for my future planning, is able to be determine the best supervised learning method which could produce the highest accuracy in determining the cervical cancer risk. So this is my Gantt chart. So this shows when and how I complete my literature review, data collection, data pre-processing, and implementing machine learning and comparing machine learning, which will be done for my Gantt chart in PSM2. That's all from me. Thank you.